Okay, we're going to review a little bit about the periodic table and um, some information that we can garner just from looking at the periodic table. We're going to look at oxygen here in just a second, so keep in mind oxygen is in our second period, and we'll talk about that in just a few minutes. So oxygen, our atomic number is equal to the number of protons. So by knowing our atomic number, we always know our number of protons. So protons will equal 8. And then our neutrons, to determine the number of neutrons we have, we will take our atomic mass. The atomic mass is equal to protons plus neutrons. So in this case, if our atomic mass is 15.9, we'll round that to the nearest number, and that becomes, so that's 16. So my atomic mass is 16 minus the number of protons, leaves us 8 neutrons. So in this case, my neutrons is equal to 8. And it is asking about a neutral atom, so there is no charge. So our protons and electrons should be equal. So our electrons will equal 8. How many orbitals does it have? And we're not going to talk about the suborbitals yet. We will talk about those next time. But the orbitals, how many periods are there, tells us how many orbitals it has. So oxygen was in the second period, so there were 2 orbitals. And we'll talk about the suborbitals next time. The molecular formula tells us how many of each atom is in the molecule. So in this case, carbon has 6, hydrogen has 12, and oxygen has 6. So to determine the molecular mass of this molecule, carbon is 1, and so you multiply those and then you add them together. So what is a mole? A mole is a number. Specifically, it's a number at 6.02 times 10 to the 23rd. It is saying I have a mole of something. It's like saying I have a dozen of something. We know that if you have a dozen roses, you have 12 roses. If you told me you had a dozen flower arrangements, we know that you had a dozen sets of flowers. So oxygen, so it's just a number, but it's a very large number. And there's no way that I could sit there and count out 10 million molecules of oxygen to figure out how many oxygens I needed for a reaction. So what we have a mole equals 1 mole equals the molar mass. So whatever the molar mass, there's that number 6.02 times 10 to the 23rd of the atoms or molecules that are there. So if you know your molar mass, 1 mole, or that number of molecules, equals your molar mass. Okay, so the next thing we have to be able to do is balance a chemical equation. The law of conservation of mass says that what we start with, we have to end with. We can't destroy it. We can't make it up. It can change. It can rearrange itself, but it's all got to be the same number on one. What we start with, we have to end with. So the easiest way to balance chemical equations is I draw a line straight down from my arrow. And then I list my elements. I have Na on the reactant side. I have P on the reactant side. I have O on the reactant side. And then I have K, O, O. K, and H. And in reality, if you have the OH on this side and on this side, and you have the PO4, these polyatomic ions on both sides, you can treat them together. And that will actually make your numbers a lot easier to deal with. So when you're balancing this equation, you can then make it NaPO4, K, and OH. Now, I'm going to say this does not always work. Sometimes the two elements in that polyatomic ion get separated and form something else. However, if you see them on both sides and there's not something extra, an extra oxygen or hydrogens, then you can leave them together. So sodium, we have 3 sodiums on the left side. PO4s, there's just 1. Potassiums, there's 1. And there's 1 OH. So on the product side, we have 1 sodium, we have 1 OH, we have 3 potassiums, and we have 1 PO4. So when we start looking at this, our sodiums, we have 3 on the left and 1 on the right, so that's not balanced. So I need to multiply my sodiums on this side times 3. I cannot just multiply the sodiums. I have to multiply the whole molecule. So I have 3 sodiums and now I have 3 OHs. Our PO4s appear to be balanced. Our potassiums are not balanced. So now I need to multiply my potassium on my reactant side by 3. So I have 3 here, I have 1 here. So I need to multiply this times 3. So that gives me 3 and then 3 OHs. So now I have 3 sodiums, 1 phosphate, 3 potassiums, and 3 oxygens. If there is not a number there, you assume it's 1. You do not have to write the ones, just like 1x in math, you don't have to write that one. But if it's written, you assume it's a 1. So 1, 3, 3, 1 would be the, so 1 mole of sodium phosphate plus 3 moles um, of potassium hydroxide plus yields 3 sodium hydroxides and 1 potassium phosphate. So this is the ratio. So if I know the ratio is 1,331, and let's say for some reason I know I have 5 moles of sodium phosphate, how many moles of KOH do I need? And I want to know how many moles of KOH do I have? Well, from the equation, we know that it's 1 mole to 3. So I have 5 moles of NaPO4. So then we take our ratio from our equation, and we know we had 1 NaPO4. So what we have always goes on the bottom, so it will be 1 Na3PO4, and then it will be 3 KOHs. So multiply across, divide down, and you should have 15 moles of KOH. So by knowing the ratio, then we can figure out how many moles, or we can figure out how many moles of one of the products we're going to have because the ratio is still the same. It would be 1 mole of sodium phosphate to 3 moles of sodium hydroxide.